Okay, hello dear students. We continue with the topic number 2, lecture to the relationship between electric potential and electric field. So, relationship between electric field and electric potential. Okay, so this is simple relation, potential difference between del V, that is equal to VB minus VA, which is equal to line integral of E dot dl negative minus E dot dl, where the integral is the line integral between A and B. So this is simple relationship. Now we prove this relation, that potential difference is equal to E dot dl. Mean if we have the value of electric field intensity E, so we can find potential by this formula del V. Okay. Now in order to prove this relationship, we just start from the conservative force. The conservative force is the force that is independent of the path followed, mean that the force that does not depends on the path followed. Okay, so it means if we have electric field lines, so if we move electric field lines, is moving from right, left to right. Okay, so this is the direction of electric field line E, and we want to move a charge from A to B point. So potential at A is VA, at potential at B is VB. When we move a charge from A to B, so we have to in order to find the potential, in order to find the potential energy U, we need the line integral of force, conservative force, and the dot dl. Mean we need to find the we have to in order to find the energy, we need F dot dl, line integral of F dot dl. If we want to find the energy, so we need integral of line integral of conservative force dot length element dl. So suppose at this point we want to find the potential energy, so we just need the electric field, because you know the electric field, direction of electric field is represented by this red arrow, and this length element, that we took small length element, because we divide path A to B into several infinitesimal small steps, and for each step, for example this kind of step, for example this is fifth step, 1 2 3 4, fourth step, for fourth step we need potential. So you need, in order to find the potential, we just take a line integral of E and RF. This F is also in the same direction, F and L, F dot L we need in order to find the potential energy. Okay, now in other words, so if you want to find the potential electric potential from potential energy, we have to divide by the Q, because potential is defined as energy per unit charge. So we divide this equation, suppose this is equation number 1, so we divide by Q on both sides. So when we divide by Q, so on the both side, so we can write UB minus UA divided by Q, which is equal to integral F divided by Q dot dl. So this F over Q is basically the electric field intensity E dot dl from A to B, and UB minus UA, that is the change in potential energy. So change in potential energy per unit charge is the potential VBA. So this is what we need, the potential. The VB is basically del V. The change in potential is equal to minus integral A to B E dot dl. So this formula is very useful if we want to find the potential difference by the electric field intensity E. So if we have the value of E, now we can find potential difference by this formula. Okay, let me explain by solving example 3. So example 3, here we have two parallel plates. The charge produces a potential difference of, so the potential difference between the plates is 50 volt, that is given here on the right side. You can see that the potential is 50 volt. So the given information is, given data is, for this problem, given information, given data is potential difference is given, that is 50 volt, and the separation between the plate is that is equal to 0.05, that is equal to, you can say that R, or you can say that D is equal to R, or D is equal to 0.050 meter. Okay, so we need the value of the electric field intensity E. So we use this formula, as we know that potential electric potential difference equal to del V is equal to del V is equal to minus ED, but we only need magnitude, so we ignore negative sign because we only need the magnitude. So V is equal to del V is equal to ED. So the previous formula, del V is equal to ED. So del V is equal to ED. So E is equal to V over D. Del V over D. Sorry, del V over D. So we have the value of potential, change in potential, that is equal to 50 volt, and the D is separation between the plates is 0.050 meter. So we just divide V and D, we get value 1000 volt per meter. So one more thing, we ignore negative sign because we only need the magnitude of electric field intensity. So no need to write the negative sign. Negative sign only shows the direction. When the charge moves from A point towards a B point, or when it moves from high potential towards the low potential, so we introduce negative sign. Okay, so no need to write a negative sign because only need the magnitude of the electric field intensity E. Okay, thank you.